In our notes today, we're going to be looking at transformations. And in general, a transformation is something that we are completing in the coordinate grid, and it just takes a shape and it changes it to a new position or a new location on the grid. So you're kind of transforming part of that shape. So some vocab that's going to be important in transformations is a pre-image. And a pre-image is the shape that we start with. So before we do anything to a shape, before we move it or anything, that's the pre-image. So think of like a prequel of a story that comes before it. And then the next word that we have is just the image. So the image is the shape that has been transformed. So you take the pre-image, you perform a transformation on it, and you get its image. A vertex is just a point on a shape, and that should be something familiar. If you're going to be listing all of the points, plural, it is called vertices. So if you hear either of those, it's just talking about the point or points of a shape. And then our final kind of vocab here that's going to be important. In the pre-image, you could call a vertex labeled A, but in the image, once it's been translated or reflected, the point will be labeled as A with an apostrophe here. But the way that we pronounce that is by saying A prime. So whenever you see A with an apostrophe above it, that means A prime. So that's in the image. It's the new point after you've done a transformation on a shape. So to get into our two types of transformations, the first type we have is a translation, and it's just a type of transformation in which an image is formed by moving every point on the pre-image the same distance and in the same direction as each of the points on the shape. A translation slides a shape across the coordinate grid. So it's going to be looking as if you took the shape and you slid it across. So one way that might help you remember that is translation has SL right in the middle and slide starts with SL. So it's kind of a way to remember it there if that helps you. In a translation, the pre-image and the image are always congruent. So it's not changing the size of the shape. It's not going to change the orientation or direction of the shape. It's just going to be sliding it across. The corresponding angles will have the same measurements, and the corresponding sides have the same measurements. That's just reiterating what our definition of congruent meant. So when you have congruent shapes, they're the same shape, same size. So for an example of an actual translation, I've given you a triangle on the coordinate grid labeled A, B, C, and it says look to the graph on the left. Record the coordinate pairs for the pre-image. Then using the pre-image points, create a new translated image. So on our pre-image, we have point A, and this point A is going to be at -8 for our x value and +8 for our y value. So the coordinates of that point are -8, 8. Point B is right here. That's at -8, 3. And point C is right here. That is at -4, 3. So those are the coordinates of our pre-image. We haven't done anything to it yet, but our directions now tell us, say, translate triangle ABC 5 units to the right and 8 units down. So what we're going to do is take each point, count 5 units to the right and then 8 units down, and that's where our new translated point is going to be. So for point A, I'm going to start right here, and I'm going to count 1, 2, 3, 4, 5 blocks over. So right now I've gone 5 blocks in that direction. So I'm right here. And then I'm going to move down 8 blocks. So 1, 2, 3, 4, 5, 6, 7, 8. That's going to mean point A prime, now that it's been translated, it's going to be right here at -3, 0. Now point B needs to do the same thing. So we have to count 5 units to the right, 1, 2, 3, 4, 5, and 8 units down, 1, 2, 3, 4, 5, 6, 7, 8, right here. And that puts B prime at -3, -5. And then for point C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So I've gone 5 units to the right and 8 units down for each of the points of the original triangle. So C prime, is at 1, -5. And we're just going to connect all the dots here to see what our new shape would look like. So now I have triangle ABC, and I split it by taking it 5 units to the right and 8 units down to get triangle A prime, B prime, C prime. The triangle hasn't turned at all, it's not facing a different direction, it's not any bigger or any smaller. You could count the units here and see, well, the original triangle had 5 units length for side AB, there was 5 boxes there, and if we count here, 1, 2, 3, 4, 5, it's the same. Same with on the bottom, we had 4 units down below, and there's 4 units here. So these triangles are congruent, and all we did was slide them across. Turn to the back of your notes, and we're going to look at reflections next. So a reflection, you've probably heard that word when you're talking about maybe looking at a reflection in a mirror. The vocab that we talked about on the front for transformations in general is going to apply for reflections as well. So again, just as a reminder, a pre-image is the image that we start with. The image is the shape that's been transformed. A vertex is a point on a shape, but if you're listing multiple, they are called vertices. In the pre-image, a vertex could be labeled as A. In the image, the corresponding point would be labeled as A prime. So we already know that if we see A apostrophe, it's pronounced as A prime. But sometimes, if you translate something twice or reflect something twice, you have A with 2 apostrophes, and that's pronounced as saying A double prime. So you might hear that sometimes. Now, to actually define what a reflection is, again, think about if you're looking in the mirror. You see yourself and you're about however far away from that mirror, your reflection is going to look like it's the same distance away, and you're going to see exactly the same thing, just flipped. So a reflection is a transformation in which an image is formed by flipping the image over a line called the line of reflection. Now something to remember, this one, reflection is a flip, so FL, and there's FL right in the middle there. So kind of with translate with SL for slide and reflection FL for flip, that might help you remember just another way to kind of help you just differentiate between the two types that we're studying this unit. So in a reflection, the pre-image and the image are congruent. So again, that's going to mean that the corresponding angles have the same measurements and the corresponding sides have the same measurements. Now the only thing that's going to look a little different here is that you're flipping it. So it's going to kind of look like a mirror reflection of the shape. So it will be facing different directions than when we just were sliding them across in translations. So our directions for our example say to look at the graph to the left, record the coordinate pairs for the pre-image, then using the pre-image points create a new reflected image. So our pre-image is what we start with. Point A is at 3, 8. Point B is at 3, 3. And point C is at 7, 3. Our first set of directions says reflect triangle ABC across the x-axis. So the way that we do that, we're reflecting across the x-axis, and that means that our line of reflection will be on the x-axis. So I'm reflecting over this line, and I just highlighted that blue. So what we have to do is take each of our points, count how many units away from the x-axis is that point, and then count that many boxes away in the opposite direction to plot the new point. So point A, we have 1, 2, 3, 4, 5, 6, 7, 8 units to the line of reflection. I'm going to keep it lined up just like here, so at the same x value at 3, but I'm going to count 8 units in the opposite direction. So 1, 2, 3, 4, 5, 6, 7, 8. So that puts my A prime point at 3, negative 8. Then for B prime, I start at point B. It's 1, 2, 3 units away from my line of reflection, so I count 1, 2, 3 units in the other direction, and B prime will be at 3, negative 3. And then finally for point C, we are 3 units away from the line of reflection. We count 3 units in the opposite direction, so we have C prime at 7, negative 3. So what you might notice is these coordinates look really similar to the pre-image. The only thing that's different is that we have the opposite y value here. So when you're reflecting across the x-axis, you keep x the same, but you change your y into its opposite value. So since all of our y's here were positive, they turned into negatives. Now we're going to look at it differently. We also need to connect our shape here too, just to kind of see it. So you can kind of see that it was flipped across that line. If you had folded a piece of paper over that line, those two shapes would line up exactly. So now in the second example, it says reflect triangle ABC across the y-axis. So it's telling us to start back at that shape that we started with. And we're this time reflecting across the y-axis, which is our vertical axis. So across this now red line. So it's the same process. We're going to start at point A. It's 3 units away from our line of reflection. So to stay lined up with it, I'm going to just go 3 units in the opposite direction. So that's going to put point A prime at -3, 8. For point B, I go 3 units to my line of reflection, 3 units in the other direction, and that's at -3, 3. And then finally for C, I have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Right here at -7, 3. So I actually mislabeled these. We already had an A prime. This point will be A double prime. We're doing a different transformation. B double prime and then C double prime. You can go ahead and connect these points to make our new triangle. And what you can see in both of these reflections, they both did something different. So the x-axis, it was reflected over that horizontal line, and when we reflected over the y-axis, it was over the vertical line. So they look different when we flip them, but you can still see that all 3 of these shapes are congruent. They're just facing different directions. Now, something that you might have noticed with the points here, when we reflected across the y-axis, the only thing that was different is that our x value changed, but our y value was the same. So it's kind of the opposite. We are just going to change x, so you just change the sign on your x value, and you keep y. Sorry, this should have said change y up here. Make sure you add that to your notes. So if you forget the keep x, change y, or change x, keep y rule, just plot it on a graph and you can count to your line of reflection. That's the easiest way to figure that out. Thanks for watching.